So today I want to talk a little bit about building a cloud with Erlang and SmartOS. And I mean, how hard could it be? Amazon did it, Google did it, probably not with SmartOS and Erlang, but they built a cloud, so how hard could it be? A little spoiler ahead of time, it can be quite hard. So it sounds easy, let's build a cloud, it's just one word, it's fluffy and nice, but it's not. 3 words to me. I'm writing Project FiFo, which is a cloud orchestration software for SmartOS in Erlang. There's my Twitter, there's GitHub, all the work I do is open source, so you can look at it. And on IRC, I am findable as licenser, even so I don't respond unless you put my name in there because I don't pay attention all that often. A little disclaimer ahead of time, some of this stuff is time travel. We go through the last 2 years I worked on it, so when I say something didn't work then, it does not necessarily mean it doesn't work now. It's my experience, it's not the ultimate truth. I might have been doubly wrong, so I think something didn't work, but it was actually working and I was just doubly mistaken. And I will say something about stuff like Clojurescript or JSON, and I don't want to start a flame war or shame a technology. It's just my experience about applying this technology to my problems. And last but not least, no dogs were harmed here. It's all animal friendly. Introduction, a few words, what is FiFo? FiFo is cloud orchestration. That means you can run a cloud with FiFo. You can have multiple hypervisors and create VMs, destroy VMs. It works for KVM, it works for zones and Solaris. It's built on SmartOS. That means it comes with a lot of nifty stuff. ZFS, the file system to use today, dtrace, which is a better version of SystemTap. And there's Crossbow, which is network virtualization. And you have zones, which is what they made out of BSD jails, what then became Linux containers. And it's written in Erlang, and I don't go into the details while this is great, because you all know that. So let's start with the first thing that went horribly wrong, and that is the fail of Clojurescript. No shaming here. So it all started as a little application in the global zone, which is like the hypervisor for SmartOS, and it was written in Clojurescript. And it had a little API over HTTP and JSON. And if Luik would be here, he would say, stop using JSON. And I did in the end, but that's how it all started. The reasons for this were pretty simple. There was a client for the API. It was the official joint client, the people building Node.js, and actually Node.js, and they're building SmartOS too. And there was a client for the API, so I just figured they use it for their cloud, I just copy it. And it was just one hypervisor anyway. It was my private server standing in a barn, and I'm not lying here, it is a barn, a little outside of Berlin, with a fiber running into it, and probably some copper wires for power. And there was Node.js in the global zone, so Clojurescript kind of looked good to me, since I didn't want it to write JavaScript. And I liked Clojure, and I wanted to try Clojurescript. So how hard could it be? I tossed in some little Clojurescript, and it kind of worked, but I had no idea at this time what Project FiFo would become. That's actually more than my hobby project for the server in the barn. This whole thing had a few slight problems. While the idea was there is everything in the global zone already, since Joint uses Node.js and they write SmartOS, so they will have all the libraries and they will have all the dependencies and the stuff you need. That turned out to be not true. There were some libraries, other libraries were missing, and then there were version conflicts between libraries in the global zone and libraries in a zone. So you ended up having to ship all your libraries, or most of the libraries, and partially even the compiled binaries for libraries interfacing with the system. So that really was not that much fun and not that easy as I expected. Another thing is, it was really hard to debug at this time, which is the main reason why I put the disclaimer in that it has changed. Back then, there were no source maps for Clojurescript, so your Clojurescript application crashed, and not the Erlang kind of crash, the bad kind of crash. You got a stack trace of about 2,000 lines of Node.js code, which you then could try to map to the compiled Node.js code, which you then could try to map to your Clojurescript code, which takes a while to do. And it is horrible. I think they have source maps now. I haven't tried it, so this point might not be valid anymore. And then the concept of SmartOS is to keep the global zone, the hypervisor layer, as clean as possible, not to clutter it up with a lot of software and a lot of applications. And this approach meant that everything was in the global zone. So you had the whole authentication, everything in one big application. Was a hell to maintain. So going through this weeks of misery, there were a few things I learned. And the first thing I hope I learned, I probably still make the mistake every now and then, try to plan before you act. So I looked at it, say, hey, there's Node.js, Clojurescript, perfect, let's do it. And it didn't turn out that well. I could have checked if the libraries were there I wanted. I could have checked if the versions are compatible between the zones and the global zone. But I didn't. I just blindly rushed into it because on the first look, it looked good. I didn't plan ahead. I also had no idea what it became. By now, it's like running hundreds of VMs somewhere. This wouldn't work. I learned that rewriting is no shame. I kind of always had the opinion that if I rewrite my code, that I have done something very wrong. Because after all, I wrote in the first place. You shouldn't have to rewrite it. I could just fix it. So rewriting is no shame. Sometimes the best option is to just say, okay, I ran into a dead end here. I failed miserably. You don't have to tell anyone else that, just yourself. I just scrap it and start from scratch. And one of the other things is what seems easy in the beginning, like Node.js in the global zone, is not always simple or right in the end. So I think there's a saying that easy doesn't equal smart, something like that. So basically, just because it looks easy doesn't mean it's good, or simple, or smart. Going on with the next cute doc is the fail of a single host. Because after how horrible it went, I figured something has to change. And what changed was I tried to abstract over it, because there's already code. I didn't quite got the rewriting part at this point. So there was this Clojurescript application, and now on top of it, I built a little web server written in Cowboy. And this web server was taking the API requests. You could configure multiple endpoints, and it was routing the API requests to 2 or 3 hypervisors. Which I didn't have, but at this point people were saying, hey, I like what you did, can you make this work with 2 hypervisors, or 3 hypervisors, or 4 hypervisors? And it was a big improvement. It was running in a zone, so it wasn't running in the global zone anymore. The whole not cluttering the global zone part kind of got better at this point. And this was a big, big, big step forward, but it wasn't quite it. The reasons are simple. There was a need for an abstraction. It was one way too big application. And if a person using it wanted to run 2 hypervisors, they had to manually point their client to one hypervisor and then to the other hypervisor, and that just wasn't practical. And as people are, they don't like consoles. Well, probably you all do, but trust me, the majority of computer users want something nice and clicky, and probably with cat pictures. Much more than a nice console, which is just faster to do. So, as I'm a slave to the masses, I put on a web console there too, which kind of looked horrible since I design as well as the slides. And I wanted to work with Erlang. It kind of took the same route as I wanted to work with Clojurescript, aside of that Erlang actually worked for this. And I'm still working with Erlang. I didn't scrap the Erlang. So my enthusiasm at this point got the better of myself, and I wanted to put something Erlang on top of it, because it's nice. I just read the book OTP in Action, which is a very good book when you begin to write Erlang, or so I think. And yes, as you can imagine, because this talk is about how horribly wrong things go, there were some, you are supposed to say problems now, problems. There was still HTTP going on between first the client and the Wiggle, that is a Erlang application, and down to the Clojurescript application. And HTTP is nice, but it's not always suitable. And it introduced a single point of failure, while before, when you had two hypervisors, each one was running a own Clojurescript application. When one hypervisor failed, the other one was not affected. So you could go on your business with the hypervisor still running. Now, when the Wiggle application, the Erlang application failed, you suddenly lost connection to both hypervisors. And as we know in distributed systems, single points of failure are not ideal. They kind of come with problems. And it did not simplify the code. One of the ideas of putting something on top of it was to make it simpler and make it more modular. But instead, it just added more complexity because with this approach, there was no way to eliminate logic out of the Clojurescript application, since all the layer was doing is a shiny API with cat pictures and routing to the hosts. The host still had to do everything, including the authentication. And trust me, if you have 5 hypervisors and have to put in the usernames and passwords for everyone on each of the hypervisors, it starts getting a mess after a time. Because it's really, really not fun. So, what did I take away or try to take away after the second episode of disaster in the Project FiFo land? HTTP is no silver bullet. Everyone uses it today, but sometimes it's better to just go to something like TCP, UDP, or a protocol which does not come with all additional constraints and all the overhead when you don't need it. There are good reasons for HTTP, but blindly using it is probably not the best idea. The second thing is to split out actually applications. When we write code, we talk about modularity and splitting problems into different modules in Erlang, and then probably different applications in Erlang. But you can go a step further and actually go and split out your application in multiple applications in the sense of the operating system, each with a special task. And it turned out that handling the authentication at the leaves of the call tree was a pretty bad idea, because I had to have the whole logic of authentication permissions through all the calls, because if it came in here, it has to check something, and it goes down, it had to check something, and it went down, and you had to check something. And that wasn't very efficient, and that wasn't very smart either, because you had to keep all the data at the leaves. And then usually we say that we want, in a big system, the leaves to do the most work. For this special case, it was a bad idea. Pushing some of the work upstream to a higher layer was actually working a lot better than doing all the work on the global zones, because we want to keep them clean. So, with all this nicely learned and some experience taken from it, the next thing that went wrong is distribution. Probably one of the hardest problems in computer science, but with my can-do attitude, I figured, how hard can it be? I mean, Basho does it with React, and even MongoDB does it, and every other database claims they do it, and probably Google does it, and Amazon does it, and if Amazon can do it, I can do it, sure. So, in the process of this, the whole thing split out further. The whole authentication that was handled in the leaves until then now went into an own application called Snarl. All the logic about deploying hypervisors, about managing memory, managing resources, IP addresses, all this kind of business logic kind of stuff went into Sniffle. And I finally took my own advice at heart and rewrote the whole stuff running in the global zone. And I scrapped the Clojurescript stuff and introduced a little Erlang application that was running in the global zone and really only doing what was needed, because authentication and logic was now handled a layer up. The reasons for these decisions were pretty simple. One thing I didn't realize before is that Erlang applications or releases are wonderfully self-contained. I could compile a release in a zone, and it would ship all the libraries, all the binaries, all it needed in one little file, one little compressed tar.gz file, but still one file, and I could put it in the global zone, extract, and it worked. There was no problem with global libraries, missing library path, and all this kind of horrible thing I had to fight with Clojurescript or Node.js at this point. It was wonderful. And a distributed system was supposed to protect against a single point of failure. If your write management, the snarl, is distributed over multiple hosts, the theory is that if one fails, the others still work, so you're not out of luck. And then, instead of having one monolithic, huge application running in the global zone, there were now a lot of little applications doing exactly one thing: the write management, the authentication, the management of the systems, running in the global zone, and doing an API. Each of them distinct from each other, no interference, no shared problems. That actually, it looked really good at this time, until there was a problem. Thank you. It worked. Come on, there was a problem with the remote too. Synchronization is really hard. So it seemed like you just put a little distributed on it and it works. Not really. So the first thing I tried was gproc. And I don't want to say gproc is bad, because I really like it, but it has a problem with leader election in the case of running gproc distributed over multiple nodes. Because you can get in a deadlock, and that gets ugly, and that breaks everything. There's a nice article on that, which I didn't wrote, but which pretty much reflects the experience I had. There's a little one here, which you can't click now, but if the slides are uploaded, there's a link at the end, and if you're interested, read the articles about the details on it. So, gproc didn't work, so I wrote a little wrapper around gproc, and I feel really proud and smart because I just solved my gproc problem. Until I figured out that introducing a quorum server introduces a single point of failure. So I made the whole circle of building a nice system, realizing it has a single point of failure, making it distributed, noticing it had a problem, introducing a single point of failure to fix the problem, which wasn't the goal. And another thing that turned out to be problematic is if you're running 3 services on 6 hosts each and have to configure all the endpoints manually, it starts to be really annoying. And it starts to be doubly annoying if you don't use configuration management or anything, but do it manually because you're developing it and have to write all the application files, and then you mistype an IP, and trust me, you will. And then something breaks, and you have no idea why until you realize that instead of 12, you wrote 21. And that's no fun. So, what did I take away from this, and what do I hope you guys take away from this? Distributed systems are hard, and probably all of you know that, and I knew that at the time, but my experience is they are always a little harder than you actually think they are. So it's like time travel sneakiness. And managing configuration is annoying, especially if you have multiple nodes, because the number of configurations you have to do is like growing exponentially. That's kind of annoying and hard to do. I learned that there are really, really, really great libraries for distribution in Erlang. I can't say if there are none in other languages, but I know in Erlang they are really good. There is gproc, which has problems with multiple nodes, but it's still pretty good. And then there is one library which has like become my all-time favorite, and I want to thank Basho for it, which is React Core. If you're writing a eventual consistent library application that is going to be distributed, do yourself a favor, and do yourself a favor and not a failure, and spend the 5 minutes to look up React Core. It will save you days of work and months of problems. It's wonderful, and it's open source. And it's what React built on, and it's what FiFo built on, and it's really nice. So we had this topic before in Luik's talk, the failure of storing JSON. And it is not as obvious as JSON is bad, because JSON is not necessarily bad. But what I did was all the data that got into FiFo came in one way or another in a JSON format. So the front end sent JSON, all the stuff on the hypervisor, since it was from Joyent, which are the Node.js guys, came in JSON, so I had JSON at both ends. I figured, why not just use JSON everywhere, store the data in JSON, and there was JSX, which is great for serializing and deserializing JSON. It's written entirely in Erlang, no nifs, no nothing. And yeah, why not? Also, everyone uses JSON, it must be good. You laugh. I laugh today too, but back then I was young and naive. I had like 5 hairs more than I do today. And it seemed obvious. Everyone uses JSON. It's wonderful. It's a solution. It's God sent. Except it's not. I made the choice based on popularity and not common sense. I didn't take a moment to sit back and think about it. And this point is not based on JSON, so if you take one thing away from it, from the talk today, other than I am a horrible programmer, please let it be, don't base choices on popularity. Think for yourself, because a million fleas eat shit. And you don't probably, I hope. So that was the biggest problem, or the biggest reason for a problem. Then the pattern matching in Erlang is a wonderful feature. If you stuff all your data in JSON, you kind of toss it out of the window because you can't really pattern match against a JSON data structure, no matter how you form it. It is lists in tuples, and lists, and tuples, and lists, and tuples, and lists, and tuples. And with any kind of keys you don't know, any order you don't know. So you toss out pattern matching, one of my favorite things in Erlang, aside of all the other favorite things in Erlang, out of the window. And there was no good library at this point, or probably I should say I did not find any good library that was there to manipulate JSON. So you ended up with key find, key delete, key replace, and recursive calls on those kind of things. And it made really horrible, ugly code compared to a simple pattern match on a record. JSON is very big and verbose, and Luik said this much better than I did, so I won't repeat too much on it, but it's big. And it is hard to represent JSON in Erlang because back then there were no maps. There was JSX who put tuples into lists. Unless it was an empty object, then it put an empty tuple in a list. And then is the other thingy which used struct and then a tuple of lists, and the other thing which used another different way to represent it. So it was really hard to map the data between Erlang and JSON. And going into a distributed system, there needed to be a way to synchronize data if it got out of sync. So in Riak or databases, you know the read repair where you take 2 datas and merge them back together. There is Statebox, which is a pretty sweet library which kind of records everything you ever did to an object or data and lets you replay it and merge it this way, but has serious limitations, and one of them is the data keeps growing and growing unless you time it out. So with JSON and data without typing or without any kind of constraints, it was really, really ugly to do. So what did I take away from this? What I took away is that modeling your data around the front end or the edges of your application is probably a bad idea. You end up doing most of the work on the data in the center. So I found it a lot smarter by now to do the opposite of what I did and just do conversion to the front-end types at the edges, convert a record to a JSON when you ship it out or when you read it in, and that works very well. JSON is no silver bullet, which kind of you might have guessed by now how much I hate it. I think it has a lot of the same problems that XML had. I don't mean a lot of brackets. I mean that people are using it for everything just because, and not because there is a reason for it. And that, at least for me, that was kind of the one thing that destroyed XML the most. And JSON is on the best path to follow in this. CRDT, which are concurrent replicated data types, are wonderful. If you haven't read up on them, There is a link at the end here, because I don't think I have the time to explain them entirely. But I only have 45 minutes and not 45 days. They are a very nice alternative. Put them in a record, and you can merge them, and you have types, and it's really, really, really a lot better than just storing some kind of data, some kind of JSON anywhere. So this is not entirely fixed by now, so I'm still having some JSON data which I didn't manage to merge out and kill, which I'm very ashamed of. Please don't toss the tomatoes yet. So finally, one big problem is the fail of cap. And no, I did not beat the cap theorem. I don't think I will until I fix my time machine and can go forth and back and just send packages in time. So cap means pretty much that you can't have consistency, availability, and partition tolerance at the same time. You have to pick two, including partition tolerance. And one of the reasons why I ended up thinking about this stuff is because React Core is great. React Core is eventual consistent, which means you give up some consistency to get availability. And that's very tempting, because when you think about it, most of the time, at least for a cloud, I think availability is more important than consistency. That you can create the VM in the cloud, and he can create the VM in the cloud at the same time is more important than you seeing his VM at the same moment. Usually you just want your VM. And it is wonderful to have the ability to trade off some consistency for availability, except when it's not, because you start off thinking everything is eventually consistent, now my life is solved, everything is good, I am in heaven. There's no more problem to be had because it's eventually consistent, so eventually it will be consistent, and it's available, so I have the best thing ever, and there are no problems anymore. And then you realize that eventually figuring out that you gave out the same IP twice kind of sucks. Because then certainly the computers you created, the VMs you created will crash and get IP conflict and everything blows up in your face. And you would certainly want to avoid that because it's not good. Same applies for things like memory on hypervisors. You don't want to eventually give the guy his memory. You want to give the guy his memory for sure. And the biggest problem with cap is that probably no one will solve this problem anytime soon. There's a nice checklist here, labeled with a 3, which is from Fred, the guy who wrote Learn You Some Erlang for Greater Good. If you ever think, hey, I think I solved the cap theorem, go through this list, make the appropriate crosses, and figure out why you didn't. So, what did I take away from this? And this is a bit more technical. The first thing I figured out, or I learned, is that the more control you have over your data, the further you can push the eventual and eventual consistency. If you know what your data represents and how it behaves, how it affects the other systems, you can make much better trade-offs and much more informed trade-offs than just storing some kind of data. The first thing I was thinking is, let's put a lock somewhere so that if he creates a VM, you can't. And I was tempted to do that until I realized that I would have introduced a new single point of failure and kind of built a eventual consistent, eventual available system, which is nothing but partition tolerant. Don't give any other big advantages. Then thinking a bit more about it, because I kind of wasn't satisfied with having a system which doesn't work either way, I realized that if you do some kind of logging and you know how the data works, you can cheat a little. For example, in the case of hypervisor memory, you only care about the memory on the same hypervisor if you're actually doing something. And if you can't reach the hypervisor, there is no point of calling it a single point of failure, because yes, you can't create the lock if you can't reach the hypervisor, but you couldn't create a VM there in the first place. So not being able to lock a hypervisor you can't reach is a trade-off you can make based on the information you have about the system. So the lock on memory of the hypervisors now is on the hypervisor, on the code running on the hypervisor. So if he creates a VM on a hypervisor, he grabs the lock on the hypervisor. If you try to do the same, it will tell you, no, this hypervisor is busy. If you can't reach the hypervisor, then it's kind of busy too. And if he's done, he is done, and you can work on every other hypervisor in the meantime. So it kind of introduces a single point of failure, but the impact of the failure is about as big as a failure, so it's not making things worse. IPs are the second thing. They are more complicated because you can't really pin an IP to a physical entity. So the idea I had here, and which is again about lock location, is that if you take your IP range, because you know it's IP range, it has a start, it has an end, there are numbers in between. So you know how the data works, and you know that you can take out only one of them once and not twice. So you have 7 systems in your distributed system, and you say, okay, I divide my IP range into 7 ranges, and each hypervisor gets their own range. You sacrifice a little availability, because if all but one IP is in use, and you only have the one left, then you depend on accessing actually this one hypervisor that has a claim on it. But if, and in the most cases that is true, you have a lot of free IP addresses, this impact on it is actually minimal. So you sacrifice a little availability to get a little more consistency at this point, but you don't toss it out of the window entirely. Okay, I have no idea how I'm in the time, but I'm about finished, which means, do you guys have any questions?
I have a question regarding JSON. So you were suggesting maps, right? If I get that right, you were proposing binary data format for Erlang to use and serialize it to JSON if somebody needs that. But in general, what would you replace JSON with? Not that I believe it's the best one, but I didn't catch what the option was.
Well, the alternative, what I was trying to say, and I probably phrased it badly, is that using JSON at the edges to communicate with a web browser is one thing. But inside your application, representing the data in some kind of Erlang that maps to a JSON directly, which is probably lists of tuples, has a lot of disadvantages. I ended up putting records everywhere because I can version them, I can have the fixed fields, I have checking against misspelled names, and trust me, I'm very good at misspelling stuff. So if I had to design a system like this again, I would internally use records everywhere, or perhaps maps today, but I haven't tried them yet because there is no R7 on.
Yeah, but for persistence, would you use that what you're describing as well?
Yes.
Okay.
Just term to binary works wonderfully, and you can put it somewhere and then binary to term and you get it back. Because that's what I used with JSON in the end too, just in a kind of horrible representation instead of a nice record. Oh, now I'm scared.
It's all right, because they're very simple. I mean, I know what Erlang is, and I know what Clojurescript is, and I know what JSON is, but I haven't a clue what SmartOS is. So I've never heard of it. So what is it?
Okay, back in the good old days, when there was Sun Microsystems, which was a kind of acceptable company which charged way too much for servers. And they developed an operating system called Solaris, which is Unix, but not Linux. And then the evil Oracle came along, and they killed Solaris. No, not only Solaris, actually entire Sun. But the brave knights of Sun were so smart to open source Solaris before they were bored. So there was no taking back from Oracle. And there are now multiple forks of Solaris. There's OmniOS, there's Illuminous, and one is SmartOS. SmartOS is specialized on cloud computing. It's a little hypervisor, like 300 megabytes installation, and everything runs in a virtual machine or zone. That's SmartOS.
I don't have to put it on the boot sector of my machine.
No, you have a USB key, or you have a...
Just run it from a file?
Yeah.
Okay. You've got it on there?
Yeah.
So you can show me?
I can show you.
And then how do you build it? So you've got this SmartOS. Okay, then you just put your application inside it.
It writes the data on the disk, but the entire operating system is either on a CD or on a USB key or on a Pixie boot, if you have more than one hypervisor, that's very nice, but yeah.
And is this related to this Erlang on Zen that was booting very quickly?
And no, it has nothing to do with Erlang on Zen.
Oh, I have one question, Heinz. It's quite obvious that you're eating your own dog food
Yes.
to control your servers in the barn
Yes.
outside Berlin. And
Not
everything.
only by now, there are actually bigger installations.
Yeah, who else is using this?
There is Lucera, which is a financial cloud infrastructure company. They are like Amazon for financial, which means expensive and fancy. They're also very fast and very performant and very expensive. They also pay for me to work on FiFo because they depend on it. It's a nice thing. There is the university, I think it's Melbourne, somewhere, please don't quote me on it, in Australia, who use it for their IT department, and they are having literally hundreds of zones managed by it. And there's another university, of which I don't remember the name, in the US. It's some kind of Christian university, and they are using it for the media department. So there are actually real-life use cases outside of my barn.
Well, everything has to leave the barn eventually.
Yes, it's a very nice barn and cheap.
Have you contacted Joyent about this?
Yes, the first thing I did before I started FiFo was talking to Joyent because I really respect the guys at Joyent. And I think they do a great job with SmartOS. And they have I don't want to call it competing product, but they have a cloud orchestration product. And the first thing I did before I started this was ask them if they are okay with it. And I got a very nice reply and a t-shirt saying, we love the idea, please go ahead, we all profit from more people using SmartOS.
And another question, did you look at OpenStack in the beginning? I mean, supporting SmartOS for OpenStack, it's a natural question for me if you're building a cloud management application.
Yes, and the answer is I believe firmly into doing one thing well instead of doing a lot of things kind of well. And I am pretty sure that the code needed to get SmartOS, because the concepts of SmartOS with mostly zones and data centers, all that kind of stuff, is kind of different from OpenStack or CloudStack or all the other cloud software, isn't worth it. You would get a kind of working thing that also does SmartOS, but I am pretty sure that neither Red Hat nor anyone is doing this applications is really interested in supporting SmartOS, because that would mean they are competing with their own product, Red Hat Linux. That would never work as well as an application tailored to how SmartOS does stuff. Okay. So yes, is a short.
So you mentioned zones several times.
Yes.
What's that?
There are like multiple types of virtualization. The most common one is hardware virtualization, where your operating system pretends there is hardware, and then on this pretend hardware runs another operating system, which you then run your applications in. That's what Amazon does. That's what Google, I think, did until they had Docker. I'm not entirely sure. I am pretty sure that's what OpenStack does with KVM. Zones are an alternative to this. They are derived from BSD jails, which is a form. You take your kernel, which is like big thing, and you carve out a space in this kernel with special permissions that still has access to a lot of parts like the hardware and can set network packages, but it is constrained. So it's like a virtual machine, but not. It's running at the same speed as your operating system, but you have your own permissions, you have your own resources. In Solaris, you have your own network stack, so all the TCP stuff is handled separately. That's an alternative to pretty much KVM or Xen, which runs a lot faster since you take out a layer of virtualization. Does that answer the question? Yes. Ish.
Have you looked into Core OS?
No.
I think it might be able to solve some of the consistency problems for you. Like
Core OS is pretty much SmartOS ported to Linux.
Yeah, and on top they use like a key value storage using Raft, like an alternative to Paxos, where you should get a lot of problems removed from your consistency availability problems. And you get nice structured containers. I think they also use Docker there.
Yeah, it's pretty much SmartOS plus Linux. But the consistency problem is in kind of a different layer. Also, I like Solaris a lot better than Linux. Which is, hey, it's my choice. Don't stone me for it. Oh. You can use your Linux also.
You said Solaris.
Okay. No more questions. No more questions? Good.
No more questions? Heinz, thank you very much.
I don't have questions.
Yeah.